Ever wondered how an app can pull up your name, your order history, and your shipping address all on one screen? I mean, that stuff is probably stored in totally different places. Well, today, we're going to pull back the curtain on the magic that makes it all happen. We're talking about database joins. So, first things first, why is data even split up like this? Well, honestly, it's all about speed and organization. If you tried to cram everything into one single gigantic table, it would be an absolute mess and super slow. So instead, we organize data into these smaller, specialized tables. But that creates a brand new puzzle. How do we connect all the dots to see the whole picture? All right, let's look at a classic example. On the left, we've got a table called employee with names and addresses. And on the right, we have fact_workers with names, branches, and salaries. You see the connection, right? They both share that EMP name column. That shared piece of information is the golden key that's going to let us link these two worlds together. And the powerful tool we use to do this, to combine these related tables based on that common field, well, that's called a join. You can think of it as the fundamental move for weaving all these separate threads of data into one single, meaningful story. Okay, let's really dive into this. We're going to start with the most common, the most intuitive type of join you will ever use. Say hello to the inner join. Think of it as a really strict matchmaker. It looks at both tables, and it will only connect rows if it finds a perfect match in the other table. If there's no match, sorry, you're not getting in. You can see it happening right here. The inner join is scanning for names that exist in both the employee table and the fact workers table. So Ram, Sham, and Hari all get highlighted because, yep, they appear in both lists. And boom, here's the final result. We get this single, unified table with the address and the work details for only those employees who had a perfect match in both places. It's clean, it's simple, it's complete, or is it? Hold on a second. If you look closely at our original tables, we had Ravi, who had an address but no work record, and we had Kuber, who had a work record but no address. But in our final combined table, they've just vanished. And this brings us to a really crucial idea. Because, sometimes the data that's missing is actually just as important as the data that matches up perfectly. See, here's the catch with an inner join. Its biggest strength, that strictness, is also its biggest limitation. It just threw out Ravi because he didn't have a salary, and it kicked Kuber to the curb because he didn't have an address. So what do you do when you need to see absolutely everyone? To solve this little mystery, we need to turn to the outer join. It's a whole family of more flexible joins, and they're designed specifically to handle this missing pieces problem. They let us keep records even when they don't have a perfect match. Now, this is where it gets really interesting. We can actually control which of the missing pieces we want to keep. This gives us some incredible precision in how we look at our data. So first up is the left outer join. Just imagine our two tables sitting side by side. This join basically says, okay, the table on the left, the employee table, is the most important one. I'm going to keep every single employee from this table no matter what. Then I'll look over to the right and see if I can find their work details. And look at that. Ravi is back in the picture. Because he exists in our left-hand employee table, he's guaranteed a spot. But since he doesn't have any matching data in the fact workers table, his branch and salary just get filled in with null, which is just a fancy database way of saying no value here. So you can probably guess what a right outer join does, right? It's the exact opposite. This time, it prioritizes the table on the right, our fact workers table. The logic is simple. I'm keeping every single work record, and I'll just pull in the employee's address if I happen to find one. And there he is, Kuber's back in the list, because his work record from that right side table was preserved. This time, his address fields are marked as null. But hang on, now Ravi is gone again. So here's the takeaway. Both the left and the right joins give us a more complete picture. But it's still, well, it's a biased view. The left join showed us all the employees, but it completely missed Kuber. The right join showed us all the work records, but it left out Ravi. So what if you want to see absolutely everyone and everything? For that, we need the full outer join. You can think of this one as the leave no one behind approach. It basically combines the logic of both the left and the right joins, keeping every single row from both tables, period. And here it is, the complete picture. We've got our perfect matches, we've got Ravi from the left table with his nulls on the right, and we've got Cooper from the right table with his nulls on the left. Finally, every single piece of data from our original tables is now represented. Okay, that was a pretty fast tour through the world of joins. So, how are you supposed to remember which one to use and when? Let's wrap all this up with a simple little guide. Honestly, a great way to think about this is to frame it as a question that you're asking your data. If you only care about perfect matches, you're asking, which employees have a salary record? That's an inner join. If you want to see all employees and their salary if they have one, you're using a left join. If you want to see all the salaries and who they belong to, that's a right join. And if you just need a complete master list of everything, well, that's a full join. At the end of the day, picking the right join isn't just a technical decision, it's really a storytelling one. You're deciding which characters and which plot points are essential to the narrative you're trying to build from your data. So the real question is, what story are you trying to tell?